Good day, everyone. You're welcome to Regina Pacis online class. Today we'll be handling vectors and further mathematics. Moving to this flex, we try to understand what vector means. For instance, here, if this is a vector M, we can say that the position vector of point M is this, or we can also represent it in this form. And the modulus of M, which is from here to here, can be represented this. Okay. Also, if we are talking about a three-dimensional vector, it means we have three axes. So in that case, we can see that the dimension of this is we have y-axis, x-axis, and z-axis. So if we are to represent this like this, we are going to have more plus c k. Alright, now let's move down to the question. Now this question, which is the most important thing I want to treat today, says that the points are situated at are situated at point A, B, and C on the same horizontal plane, such that AB, a vector, is represented as 8 km, that is the magnitude, and this is the direction, that's the angle, and BC with this magnitude and direction. So we are asked to find AC. We correct it to three significant figures and find the bearing of C from A. Now the solution. So when you try to represent this in a graphical form, we can see that we have been told that the point A, okay, is this, and the bearing of B from A is 60 degrees. So this is the point of the starting point. The movement goes from A to B, and from B to C. So once we enclose this triangle, it means that we move from A to B, B to C, and C to A. So why we are asked to find AC? AC is from here to here, and according to calculation with vector, the vector AC is equal to AB plus BC, as you can see here. So now let us talk about the position vector of AB and AC. The position vector of AB is 8 sine 60 I, that's in the direction of I, the x-axis, and 8 cos 60 j. Let me explain. Can you go? We are looking for, this is the vector B, and we are looking for the x dimension and the y dimension. This is the x dimension, okay? From here to here is x dimension, and from here to here is the what? Y dimension. This is measured in what? I. This is measured in what? J. So using the Pythagoras, we know that this is 60, and this place is also what? 60. Okay, so using the Pythagoras, we can find y and x. Also, in this case, this is the vector C. We are meant to find the what? The x dimension, okay, measured in what? I, and the y dimension measured in what? J. So, knowing that this is 60 and knowing that this is 130, so 180 minus 130 gives us 50 degrees. So using this 50 degrees, we can use the SOHCAHTOA, not Pythagoras. We use the SOHCAHTOA to find x dimension and y dimension. Okay? So now you have to observe that in this case, this moves like this. Okay, this is this direction. And for this one, this is this direction. For this particular one, this main vector goes like this. So this moves from here to here, okay? And from here to here goes this direction. This is very important because it's going to tell you the sign the x component and y component is going to be. This is positive, this is negative, and this is positive. Now, if you want to know how I got this sign convention, you take a look at this diagram. You can see this is the positive, this direction is positive for y-axis, negative for y-axis, and this is negative for x-axis and negative for x-axis. Sorry, positive for x-axis. Alright, so Now we have that AB has the x dimension, that is 8 sine 60 I. Okay, I means in the x direction, J in the y direction. So when you find 8 sine 60, you have this, 8 cos 60, you have this. Also for AC, the x dimension is 12 sine 50 I, and the y dimension, which is the negative, that's this. Okay, this is the y dimension, this is the negative. So we have minus 12 cos 50. Once you simplify this, you have this. Once you simplify this and this, you have this and this. So now we are going to calculate AB plus BC. According to vector calculation, AB plus BC means you are going to, okay, this is I. You are going to sum I and I component and sum K and K component. There is a mistake here, please. This is not K, this is J, okay, because it is not 3 dimension but 2 dimension. So this is what? J, please. So once you sum this, you have this. Once you sum this, you have this. Now we have that AB plus BC is this. From equation 1 already told us that AC is equals to AB plus BC. So that we have that AC is equals to AB plus BC, which we got this, okay? Now we have AC is equal to this. Then we are meant to calculate the modulus of what? AC. The modulus of AC means to what? When you square the x component and they add it to the square of the y component, you find the square root. So now when we do that, we have this, okay? And once we simplify this, we have this. Please, it's very important to understand this diagram. If possible, take a screenshot and try to understand this diagram very well, because you can see that the modulus of M is equals to A squared plus B squared all squared. Now the last question, this is how you solve the last question. The last question says we should find the bearing. Okay, we are going to use the sine rule. In short, you have to take this as an assignment. The sine rule, when you employ the sine rule on this diagram, okay, when you employ the sine rule on this diagram, you are going to get the answer for C. Thank you.